Welcome to lesson 2.4. This is reflection from spherical mirrors. After all the skills that we've been picking up, we finally have enough knowledge to start throwing light at a curved mirror, and we'll see exactly how it behaves. We've seen, talking about this earlier, that whenever a ray comes in at a mirror, it will come in on one side of the normal line, and it will reflect out on the other side of the normal line. So let's just take a ray of light here, pink light. This ray comes in, left to right, strikes the mirror at this point, and now it's going to reflect out. To decide how it's going to reflect out, you need to draw, as accurately as you can, a normal vector, a normal line for this mirror. This ray comes in at a certain angle above the normal line. It's going to reflect out at exactly the same angle below the normal line. So, trying to do this as neatly as I can. That looks pretty fair. It comes in a certain angle from the normal. It comes out a certain angle below the normal. Remember, I'm drawing the reflected rays a little darker than the incident rays to remind you that the light's losing energy. It's losing amplitude every time it reflects out. So, that's a reflection off a curved mirror, a spherical mirror. Let's try another one and see what happens if we put in some light in a different place. Green ray comes in. We're in a different spot on the mirror now, so we have to construct another normal line. That looks pretty good. And then our reflected ray comes out on the other side at the same angle that it came in. Well, they had to cross somewhere. It's interesting that they cross right on the midline like this. Let's try one more ray, and we'll see if we're onto something here. If I send in a ray, let's go for the bottom this time. Ray of orange light comes in along the very bottom, strikes the mirror. The normal line to the mirror at that point is right about there. And so when that ray reflects, trying to get the angle, I'm concentrating on the angle right where the ray struck the mirror, and I'm trying to get the angle below and the angle above to look exactly the same. And it happened again. This is not a coincidence. This is a fundamental rule about spherical mirrors. Whenever rays come in parallel to the axis, you notice that all of my incident rays were horizontal in this case, they will always reflect out through a common point in the middle, and this point is the one that we call the focus. When we use the word focus in English, we talk about gathering all of something into a single spot. That's precisely what this mirror is doing. All the light that you throw at it that comes in parallel to the axis gets gathered together in this one point. Every ray that comes in parallel will go out through the focus. That's one of our reflection rules that we're going to need as we start drawing ray diagrams. And the rule is in parallel, out through the focus. If it comes in along the axis, it will go out through this focus point guaranteed.